what we want to do here for a few minutes, talk about subnetting and some different methods and why they work. So what we're doing with a subnet is we're going to create, let's see if I can do this, create broadcast domains. And we've talked about broadcast domains. So what we're doing also is creating efficiency. If we're using private addresses, quite honestly, probably not going to be a real issue. But if we're paying for these things, we kind of want to get our money's worth. So what we're going to do, and we've talked about the classes, the class A's, the B's, and the C's, and the subnet mask and the CIDR notation. The CIDR notation with /4 would represent a class C, a 255.255.255.0, which gives us 8 ones and 8 ones and 8 ones, or 24 ones, how many ones are in the subnet mask. So what we now want to do is take this network, and we'll say it's a 192.168.1.0, and we want to break this last octet up into smaller components, smaller broadcast domains. So we're going to move the subnet mask to the right. And depending on what we do, we know we have 8 digits, 8 bits in order to be able to work in this thing. So 1, 2, 3, 4, 5, 6, 7, 8. And each one of those can be a 0 or a 1. So each of them represents a 2 here in the first. A 0 or a 1, we can have 2 different digits. As we go across from right to left, we double each time. So this one, how many can we have? Not the value, but how many. We can have 2 here, and then we can have 4, 8, 16, 32, 64, 128, and then 256. And 0 being one of the things that we use, the value goes from 0 to 255. So 0 to 255 are the values that we can have in these things. As we move, and this one would be all zeros in the subnet mask, which is going to give us an entire 8 bits for the network address, 0 to 255. And we know that we have the 2 reserved addresses. The 0 is the network, and the 255, the all ones, is going to be the broadcast that we're going to use for these things. So we have these things. As we move the subnet mask in here, and we'll just do 2 bits here, then we don't have as much capability for the host addresses. So we can't create addresses. We're going to move them in here and be able to have more networks, more broadcast domains. And in this case, we can have in here the 1 and the 1. We can start this thing out with a 0, 0, and the host bits are all zeros for the network address. So 0, all zeros would be the 192.168.1.0. We could then do a 0, 1, and in our 1, 2, 4, 8, 16, 32, 64, the value of these 128 would be a 64. And then we could do a 1, 0. Or we could do a 1, 1. So in that case, we would have a 0, and then we would have a 64, and then we would have a 128, and then we would have a 192. And hopefully you kind of see the progression of what goes on here. And interestingly enough, 2, 4, 8, 16, 32, 64, this has a 64 things in it, 64 total addresses. Those 64 addresses will go from 0 to 63, which gives us the 64. Increment 2, 4, 8, 16, 32, 64. And hopefully you see the relationship here. So we can now use the increment. We can just go in here and say, okay, I know that I have 1, 2, 3, 4, 5, 6 bits, 2, 4, 8, 16, 32, 64, 2 to the 6th, 2 to the 6th equals 64. So I can now write all of my network addresses. I'm going to start with a 0, and then we'll have a 64, and then add 64 to that, 128, Add 64 to that, it's going to give us the 192. Add 64 to that, we'll get to 256, which is obviously the end of the line. So what are the addresses that we can use in these things? Because typically we're going to need a network address. We're going to use the first host address, the last host address, and the broadcast. So the first host, no big deal here. We just add 1 to the network address. So the first one here would be 1. The next thing I like to do is the broadcast. Whatever the next network address is, minus 1 is going to be the broadcast address up here. So 63 would be my broadcast, 1 less than the broadcast. We'll do it. 62 is going to be the last. So the usable assignable host addresses, 1 through 62. 0 would be the network address. 63 would be the broadcast. Next one down here, since we know that 64 is the network address, we can go in here, and 65 would be the first usable. 128 is the next network. 127 would be our broadcast. 126 would be the last usable. And a couple of observations here. The network addresses, you notice, are all even. And when we do the broadcast addresses, the broadcast addresses are all going to be always going to be odd. Just kind of a little sanity check that goes along with these things. Do one more here. 128. First usable would be 129. Next network is 192, so the broadcast will be 191. The last usable address would be 190. So kind of a quick and dirty overview. I want to do a couple of other things. If you keep watching for this, let me get rid of all of this, clear the canvas here, and I want to bring up a spreadsheet that basically does the same thing. It just changes color so that we can see how much is network and how much is broadcast. So in this case, we got 192.168, 1 network, and we're going to subnet it. Let's say we need 4 networks. So 4 networks we would put in 2 bits for this thing. So we now have made the network address longer, but we've also reduced the size that we can use for host addresses. The network address here we can use for this thing, and I can just bring these down to give us the 192. Those are 255s. Never mind, we want to bring the other ones down here too. That's not what I wanted to do here. So let's try put the zeros in here again. Too many things running not there. And we'll do a 0. 120. The network address will be 192. So let me try to undo what I have just done here. Be able to. Okay, too many things running, and it wouldn't let me do what I wanted to do. So, but same sort of thing that we did. This I've copied the first part. We're going to subnet the 192.168.1 network over here. So what we can do is move. Got the IP address here. We got the subnet mask. We can move the subnet mask to the right. We'll go a 1 and a 1, and it changes colors to represent that we've now moved the network. So we now have the ability from this network address to create subnets, the subnet indicator or the subnet component. The values of it can be the 0, 0 here, and then if we do the broadcast is going to be that element where the host addresses are all 1. So we'll put all 1s in here to represent that. So this broadcast address will be 63. The first usable address is the network address plus 1. And the last usable address is the broadcast address minus 1. And again, the reason the broadcast or the last usable has to be even, all these others are even except the last digit, the 1 value for these things. So we have the 0, 63, and then the number of bits 2, 4, 8, 16, 32, 64. 0, 2, 63 gives us the 64. If I now go in here and for the network address put in a 0, 1, then the whole world changes here for these things. So I have the network address 64. Hey, 248 1630 248 1632 64. Next network address 64, the 01. So then we can do the 10, which should give us the 128 to do that. So we'll get that, and we get the 128, and we can do the 10 here, and the 10 here, and the 10 here, which gives us the 128 to 191. Just as oh yeah, by the way, when I go to the next network address, and my broadcast here was 191, a 11 here is the next network address, which would be a 192. So one less than that gives me the broadcast address for the previous network. And that's why writing these things kind of becomes a relatively big deal. So the increment here, 248 1632 64, 2 to the number of bits that are in the host address. I'm using the last octet because the arithmetic is easier. You can do this same thing in any of the octets that you need to do, that you want to do with each of these things. So as a last one, let's look here at the variable length subnet mask, and we'll use the to address and then the different sections of our company, different number of hosts, the required number of hosts for each of these things. The first thing that I want to do is to draw a box over here to keep track of the addresses. This variable length is an easy way to get overlap, or an attempt to get overlap. So in these, the required hosts, and when I look at this, and I'm going to try to scrawl in here with my pen, I'm not the best handwriting in the world, but the 192, 168, 2 isn't going to change. Only the last digit here is going to change. But we're going to start out with the network address of 0, which means that our first host is going to be 1. We need 52 addresses, 248 1632 64 is what we have to do. So 64 would be the next network that we're going to use for this thing. And what I'm going to do is go over here and draw a line, hopefully draw a line that says, hey, we've taken out here 0 to 63. The next one is 64 addresses. So in this case, 64, the next network that we'll have, one less than that, the broadcast will be 63. The last host, one less than the broadcast, 62, when we have these things. So the maximum number of hosts here, 64 minus 2, which is going to give us the 62, and then the CIDR notation, 248 1632 64. I'm doing my fingers here, 6 bits, 2 bits for the network. So we're going to have the 24, the 8, the 24 plus 2, which will give us a /26 for this one. Next network, marketing, 248 1632 won't do it, 64. We've got to do the same thing, but our network address now is going to be the starting point here, which would be 64. The first host would then be 65. So we've got to go in here and take out another 64 addresses. So 64 plus 64 was going to be 128, will be the next network address. So we get the 128 here for the next network. One less than that, we're going to go in here, the network 64 to 127 is what we're going to do, which gives us the 64 addresses. So the broadcast address in this one will be 127. The last usable host will be 126. The maximum host is still going to be 62, and the CIDR notation will be /26. Just as a kind of a curiosity thing, the increment here is 64, so the increment is 64. If we take 256 and subtract the increment, 64, 6, 2, 192 is going to give us the subnet mask. The 2 bits using our 1 to the value 1248 16 32 64 128. The 2 bits, we add this up, the subnet mask will be 192. Or we can subtract the subnet mask from the 256 and get the increment. Either way is going to work for these things. So this one, 127. The next network address, and we can just bring it over for the admin, we're going to start at the network 128. And we need 24, 2, 4, 8, 16, 32. So our increment here is going to be 32. Draw another line here, and we're going to add 32 to 128, which I think gives us 160 for that. So 160 will be the next network address, and we're going to have to put that one in here, 160. But when we do that, our broadcast, 1 less than the 160 will be 159. So in this one, we're going to go from 128 to 159 would be the range of addresses that we would use. The last host, 1 less than that, will be 158. The first host here would be 129. The maximum hosts here is going to be 32, 2, 4, 8, 16, 32 minus 2 would be 30. And since we now have added one more bit to the subnet mask, and again we can use the 256 minus 32 to get the subnet mask, which is going to give us, what is it, 224, and 224 is 123. We add the 3 here, would be a 4. So we have the next network address. HR needs 11 addresses. 2, 4, 8, 16 is the best that we can do. So we'll go in here and take some more addresses out. Fill it in a bucket is kind of what I think of this, or taking the addresses out and the lines here to prevent the going over for these things. So we add 16 to the 160, which is going to give us a 176 here. So the network, or the addresses here from a 160 from the network up to the broadcast, which will be 175 for these. So 160 here, the first usable address would be 161. We know what the next network is, so the broadcast 175. 1 less than the broadcast, 174 is going to be the next address. 248, 16 minus 2, the maximum usable. 14, we've gone over one more, so we're going to have /. Accounting needs 4 addresses. 24 won't work. We have to go with the 8. I'm going to go ahead and do this one because it just makes it easier to do these things. So we're going to go in here and we add 8 to this one. The next network address will be 184, I believe. 8 and 6 is 14, 184. So this one is going to go from 176, the network address, to 183, the broadcast address that we're going to use. So in this case, the network address, we got that 176. We could have put that in a little earlier. The first host is going to be 177 that we would use for it. The broadcast, 1 less than the next network address, 183. The last usable host, 1 less than the broadcast, 2. The maximum host, 248 minus 2 is 6. And we can go here and what's going to be the CIDR 248 that we would have for this thing. So it's going to be 24 plus the 1, 2, 3, 4, 5, which would be in here. So the 24 we already have, plus the 5 bits that we have taken away, which is going to give us a /. So that's kind of an overview in 184. We still have a bunch of addresses left. So we have, we could go up to the end here, to the 250, 255 would be the broadcast that we would be using for these things. And that leaves us still, obviously, a number of addresses that can be used for these. So hopefully this has been useful as an overview for what goes on or what we can do with subnetting, what we're doing with this and the process. You can either use the binary method, which I was doing in the spreadsheet, or use the increment method. How many host bits do we have? And 2 to whatever that power is the increment. That's going to be the network addresses. Variable length subnet mask, increment method is probably the easier way to do that. Anyhow, thanks for taking a look, and hopefully this has been useful.